Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation using variation of parameters method. So let's get going. Problem: solve y double dash minus 2y dash minus 3y equal to 64x e power minus x, or d square minus 2d minus 3 into y equal to 64x e power minus x using variation of parameters method. So here we are given a differential equation of order 2. Given differential equation, y double dash minus 2y dash minus 3y equal to 64x e power minus x. Consider it as equation 1. We can write y double dash as d square y by dx square and y dash as dy by dx, right? Now let's write d square y by dx square as capital D square y, where d is a differential operator, and dy by dx can be written as dy minus 3y equal to 64x e power minus x. Now take y common from all the three terms of LHS. We'll get d square minus 2d minus 3 into y equal to 64x e power minus x. Consider it as equation number 2. Equation 1 in operator form is our equation 2, right? Now, okay, this is in operator form, right? Say f of d into y equal to some function of x, where f of d is d square minus 2d minus 3. Right? Let's now write the homogeneous equation of equation 2. D square minus 2d minus 3 into y equal to 0. Consider it as equation number 3. Now, we'll find the solution to the homogeneous equation using the auxiliary equation, and later using the solution of homogeneous equation we'll get the solution of, the general solution of the given equations. Okay. Now coming to the auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square minus 2d minus 3, right? Let's replace the differential operator d by m, so that we'll get f of m equal to m square minus 2m minus 3. Then the auxiliary equation becomes m square minus 2m minus 3 equals to 0. Now we need to find roots to this equation. Let's write minus 2m as plus 3m, minus 3m plus m. Now take m common from the first two terms, we'll get m times m minus 3, and we can write last two terms as it is. This gives us m minus 3 into m plus 1 equal to 0. Now equate each factor to 0. From m minus 3 equals to 0, we'll get m equal to 3, and from m plus 1 equal to 0, we'll get m equal to minus 1. Then m equal to 3 minus 1 are the roots of our auxiliary equation, or m equal to minus 1, 3 are the roots of our equation, right? The roots are real and distinct. We know that when two roots, say m1 and m2, are real and distinct, then the solution to homogeneous equation looks like one constant into e power 1 root into x plus another constant into e power another root into x. Here we are taking C3, C4 instead of C1 and C2 because we want C1 and C2 to appear in the last general solution, right? Now coming to the solution to our homogeneous equation. the solution to homogeneous equation. Equation 3 is y equal to c3 e power 1 root, say minus 1, into x plus c4 e power 3 into x. Or we can write this as y equal to c3 e power minus x plus c4 e power 3x. Okay, therefore y equal to c3 e power minus x plus c4 e power 3x is a solution to a homogeneous equation. Let y equal to, now replace the constants or parameters with some functions of x, a and b. We'll get y equal to a e power minus x plus b e power 3x, right? Be the general solution to our problem. Where a and b are functions of x. We are saying that y equal to a power minus x plus b e power 3x is the solution to, the general solution to equation 1, which is nothing but it is a solution to equation 1. So it satisfies equation 1, right? So now we'll find y dash and y double dash using 1. And later we'll substitute y dash, y double dash in equation 1. We have y equal to a power minus x plus b power 3x, right? We need to find y dash. Y dash equals to a power minus x dash plus b e power 3x dash. So here we need to find derivative of product of two functions. Here also we need to find derivative of product of two functions. So we are going to apply u v dash formula, which is u dash v plus v dash u, right? This gives us a dash e power minus x plus a into e power minus x dash plus b dash e power 3x plus b into e power 3x dash, which gives us a dash e power minus x plus a into derivative of e power minus x with respect to x is minus e power minus x plus b dash e power 3x plus b into derivative of e power 3x with respect to x is 3 e power 3x. This gives us a dash e power minus x plus into minus minus a e power minus x plus b dash e power 3x plus 3b e power 3x, right? Now I'll just remove the brackets. You can just avoid this step if you feel it's unnecessary. If it is avoidable, you can just skip this step, okay? Now write the terms involving a dash and b dash. We'll have a dash e power minus x plus b dash e power 3x. Now write the terms involving a and b. We have minus a e power minus x plus 3b e power 3x, right? Let a dash e power minus x plus b dash e power 3x equals to 0 considered as equation 4, so that a double dash b double dash will not appear while finding y double dash, and y dash becomes 0 minus a e power minus x plus 3b e power 3x, right? Or y dash equals to minus a e power minus x plus 3b e power 3x. So we got y dash now. We have y dash equals to minus a e power minus x plus 3b e power 3x, right? Let's now find y double dash. y double dash equals to minus a power minus x dash plus 3 into b e power 3x dash. Here also we need to find derivative of two functions. Right? So here also we will apply uv dash formula, which is u dash v plus v dash u. Now let's apply the formula. We'll get a dash e power minus x plus a into derivative, e power minus x dash plus 3 times b dash e power 3x plus b into e power 3x dash, which gives us minus of a dash e power minus x plus a into derivative of e power minus x with respect to x is minus e power minus x plus 3 times b dash e power 3x plus b into derivative of e power 3x with respect to x is 3 e power 3x, right, which gives us minus of a dash e power minus x plus into minus minus a e power minus x plus 3 times b dash e power 3x plus 3b e power 3x, right, which gives us minus a dash e power minus x minus into minus plus a e power minus x plus 3b dash e power 3x plus 3 3s are 9b e power 3x. Let's now write the terms involving a dash and b dash. Firstly, we'll get minus a dash e power minus x plus 3b dash e power 3x. Now write the remaining terms plus a e power minus x plus 9b e power 3x. So we got y double dash here. We have equation 1, y double dash minus 2y dash minus 3y equal to 64x e power minus x, right? Let's now substitute y dash and y double dash in it. We get y double dash minus a dash e power minus x plus 3b dash e power 3x plus a e power minus x plus 9b e power 3x minus 2 times y dash minus a e power minus x plus 3b e power 3x minus 3 times y a e power minus x plus b e power 3x equal to 64x e power minus x. This gives us minus a dash e power minus x plus 3b dash e power 3x plus a e power minus x plus 9b e power 3x minus into minus plus 2a e power minus x minus into plus minus 2 3s are 6 b e power 3x minus 3a e power minus x minus into plus minus 3b e power 3x equal to 64x e power minus x. This gives us minus a dash e power minus x plus 3b dash e power 3x plus a e power minus x and plus 2a e power minus x is plus 3a e power minus x, and we have one more a e power minus x, right? We have minus 3a e power minus x. Now coming to b e power 3x plus 9b e power 3x minus 9b e power 3x minus 3b e power 3x gives us minus 9b e power 3x and the RHS term 64x e power minus x. So here Plus 3a e power minus x minus 3a e power minus x gets cancelled. Likewise, 9b e power 3x and minus 9b e power 3x gets cancelled, and this results to minus a dash e power minus x plus 3b dash e power 3x equal to 64 x e power minus x, considered as equation 5. Now we can solve equation 4 and equation 5 to find a dash and b dash. Later we'll find a dash using a and b using b dash. Okay, we'll find a using a dash and b using b dash otherwise, right? Now let's solve equation 4 and 5. We have equation 4 and 5. Now we are going to solve 4 and 5. So here plus a dash e power minus x and minus a dash e power minus x gets cancelled, and we'll get b dash e power 3x plus 3b dash e power 3x equal to 64 x e power minus x, right? This gives us b dash e power 3x plus 3b dash e power 3x is 4b dash e power 3x equal to 64x e power minus x. Okay, now let's take 4 and e power 3x to RHS. We'll get b dash equals to 64 by 4 into x e power minus x into 1 by e power 3x. Okay, this gives us 16 x e power minus x into reciprocal of e power 3x is e power minus 3x. This gives us 16x. Here we are having e power minus x into e power 3x. Sorry, e power minus 3x, right? We can write this as e power minus x minus 3x, which gives us e power minus 4x. So you'll get e power minus 4x here. Therefore, b dash equal to 16x e power minus 4x. Let's now find a dash just by substituting b dash in equation 4. We have equation 4 a dash e power minus x plus b dash e power 3x, right? We can write this as a dash e power minus x equal to minus b dash e power 3x, right? Since b dash equal to 16x e power minus 4x, let's replace b dash now. We'll get minus of 16x e power minus 4x into e power 3x. Okay, this gives us minus 16x e power minus 4x into e power 3x. E power minus 4x into e power 3x can be written as e power minus 4x plus 3x, which gives us e power minus 4x plus 3x is minus x. So just replace the terms under, the term under bracket with e power minus x. Right, now we are having a dash e power minus x equal to minus 16x e power minus x. You can cancel e power minus x from both the, from LHS and RHS, or you can just take e power minus x to RHS. We'll get a dash equals to minus 16 x e power minus x by e power minus x, where e power minus x gets cancelled, and you'll get a dash equals to minus 16x. Therefore, a dash equal to minus 16x. So we got a dash and b dash. Now let's find a and b. We'll find a using a dash and b using b dash. We have a dash equal to minus 16x. A dash is nothing but derivative of a with respect to x equal to minus 16x. Let's now separate the variables by taking differential dx to RHS. We'll get dA equal to minus 16x dx. Here the variables are separable. Let's now perform integration. Integral dA equal to minus 16 integral x dx. This gives us integral dA equal to minus 16 into integral x dx is x square by 2 plus some integral constant says c1. This gives us a equal to minus 8 x square plus c1. Therefore, a equal to minus 8 x square plus c1. Let's now find b using b dash. We have b dash equals to 16x e power minus 4x. B dash is nothing but derivative of b with respect to x. Let's now separate the variables by taking differential dx to RHS. We'll get db equal to 16x e power minus 4x into dx, where the variables are separable. Let's now perform integration. So here we are going to evaluate integral x e power minus 4x separately for our convenience. So here we are going to apply integration by parts formula. Integral u dv equal to uv minus integral v du. The integrand is of the form product of polynomial and exponential function. So consider the polynomial function as u and the remaining part as dv. We'll get u equal to x and dv equal to e power minus 4x dx here. Differentiate u or u equal to x with respect to x. We'll get du by dx equal to derivative of x with respect to x is 1. This gives us du equal to dx. And here we are going to integrate on both sides to find v. We'll get v equal to integral e power minus 4x dx is e power minus 4x by minus 4 or minus 1 by 4 into e power minus 4x. Let's now apply the formula. Integral u into dv equal to uv x into minus 1 by 4 e power minus 4x minus integral v minus 1 by 4 e power minus 4x into du, this dx. This gives us minus x by 4 e power minus 4x minus into minus plus 1 by 4 integral e power minus 4x dx, which gives us minus x e power minus 4x by 4 plus 1 by 4 into integral e power minus 4x dx is e power minus 4x by minus 4, which gives us minus x e power minus 4x by 4 plus into minus minus e power minus 4x by 4 4s are 16. Right? Therefore, integral x e power minus 4x is minus x e power minus 4x by 4 minus e power minus 4x by 16. Now we are going to apply this, or we'll just replace integral with the result obtained from a. Okay. Since integral x e power minus 4x dx is minus x e power minus 4x by 4 minus e power minus 4x by 16, the above equation becomes integral dv be equal to 16 times minus x e power minus 4x by 4 minus e power minus 4x by 16 plus some integral constant says c2. This gives us minus 16x e power minus 4x by 4 minus 16 e power minus 4x by 4, sorry it's 16 right, by 16 plus c2. This gives us minus 4x e power minus 4x minus e power minus 4x plus c2. Therefore, b equal to minus 4x e power minus 4x minus e power minus 4x plus c2. We got a and b. Let's now find the general solution using y equal to a power minus x plus b power 3x. Therefore, the general solution is given by y equal to a power minus x plus b power 3x. Now substitute a and b here. We have a minus 8x square plus c1 into e power minus x, and b is minus 4x e power minus 4x minus e power minus 4x plus c2 into e power 3x. This gives us minus 8x square e power minus x plus c1 e power minus x plus into minus minus 4x e power minus 4x into e power 3x minus plus into minus e power minus 4x into e power 3x plus c2 e power 3x, right? E power minus 4x into e power 3x is repeating twice. Let's simplify it. You can write this as e power minus 4x plus 3x, which gives us e power minus x, because minus 4x plus 3x is minus x. Now just replace e power minus 4x into e power 3x with e power minus x. This gives us minus 8x square e power minus x plus c1 e power minus x minus 4x e power minus x minus e power minus x plus c2 e power 3x. Let's now write the terms involving c1 and c2. Firstly, we'll get c1 e power minus x plus c2 e power minus, sorry, it's 3x. Now write the remaining terms. Minus 8 x square e power minus x minus 4x e power minus x minus e power minus x. Take minus e power minus x common from all the three terms of, from the last three terms. This gives us c1 e power minus x plus c2 e power 3x minus e power minus x times, or e power minus x of 8x square plus 4x plus 1. Or you can just write this as c1 e power minus x plus c2 e power 3x minus of 8x square plus 4x plus 1 into e power minus x. Therefore, y equal to c1 e power minus x plus c2 e power 3x minus of 8x square plus 4x plus 1 into e power minus x is the required solution. This completes the problem. So we have seen a problem from variation of parameters method in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.